Now that we understand what an inequality is, the next question is, how do we actually solve one? Before learning the algebraic method, let's understand what a solution of an inequality really means. A solution is simply any value of the variable that makes the inequality true. For example, consider the inequality 30x is less than 200. If x is 2, then the left side becomes 60, which is less than 200, so 2 is a solution. If x is 5, we get 150, which is also less than 200, so 5 is a solution. But if x is 7, the left side becomes 210, which is not less than 200, so 7 is not a solution. The collection of all values that satisfy an inequality is called its solution set. You may notice that we found these values by checking one number after another. This method is called the trial and error method. Although it works for very simple questions, it becomes slow and impractical for larger problems. Imagine checking hundreds or even thousands of numbers. That is why we need a systematic algebraic method. Before solving inequalities, let's recall the rules we already use for equations. If we add or subtract the same number from both sides, the equality remains true. Similarly, if we multiply or divide both sides by the same non-zero positive number, the equality also remains true. These same rules also apply to inequalities, but there is one very important exception. When we multiply or divide both sides by a negative number, the direction of the inequality sign must be reversed. This is one of the most important rules in the entire chapter. But why does this happen? Let's understand with a simple example. We know that 3 is greater than 2. Now multiply both numbers by -1. We get -3 and -2. Look carefully. Now -3 is actually less than -2. The relationship has changed. So whenever we multiply or divide by a negative number, we must reverse the inequality sign. This is not a formula to memorize, but a consequence of how negative numbers behave. Now let's solve our first inequality. Consider 30x is less than 200. Dividing both sides by 30, which is a positive number, gives x is less than 20 by 3. Notice that the inequality sign did not change because we divided by a positive number. If x represents natural numbers, the possible solutions are 1, 2, 3, 4, 5, and 6. If x represents all integers, then every integer less than 20 by 3 is a solution. Now let's solve another example. We have 5x minus 3 is less than 3x plus 1. First, add 3 to both sides. This gives 5x is less than 3x plus 4. Next, subtract 3x from both sides. We get 2x is less than 4. Finally, divide both sides by 2. Since 2 is positive, the sign remains unchanged and we get x is less than 2. If x belongs to real numbers, every real number smaller than 2 satisfies the inequality. IN. Now consider one more example. 4x plus 3 is less than 6x plus 7. Subtract 4x from both sides. We get 3 is less than 2x plus 7. Next, subtract 7 from both sides. This becomes minus 4 is less than 2x. Finally, divide by 2 to obtain minus 2 is less than x, or simply x is greater than minus 2. Notice that throughout these examples, we never change the inequality sign because we only divided by positive numbers. The sign changes only when a negative number is involved. Remember this carefully because it is one of the most common mistakes in examinations. In the next video, we'll learn how to represent the solution of an inequality on the number line, solve graphical questions, and understand practical word problems based on linear inequalities.